Alright, for this first video, we are going to do standard 2. It is just a help video, so I really hope you've practiced this out first. We are going to solve question number 1. These are on the back. So the first thing is you have to know that the absolute value has two cases. There are two numbers inside this absolute value that can be the distance of 17, meaning equidistance from 0. So those two scenarios are 17 and negative 17. So the first scenario, we're going to just take 2n minus 4 equals 17. And the second scenario, take the same thing that is on the inside of the absolute value, equal it to negative 17. So we're going to solve each one of these out. So when you solve the second case, when the number inside the absolute value brackets is equal to negative 17, you get negative 6.5. And then when you solve the first scenario of that number being exactly what it is, 2n minus 4 equals 17, you get 10.5. So now what we do is we take both of these values and we plug it into the original problem. And I use my calculator for this. So on my calculator, I like to do 2 times 10.5 minus 4, 17. So the absolute value of 17 equals 17. That works. And then 2 times negative 6.5 minus 4 is negative 17. The absolute value of negative 17 equals 17. So these both work. So since both of these work, my answers are going to be n could equal 10.5 or negative 6.5. Make sure you always check your answers. Alright, on this one here, before I can do any solving, I gotta do the absolute value bars and get them absolutely by themselves. So isolate. Alright, so now that I've done that, I'm going to take and solve each scenario. So the first scenario is 4y minus 2. Let's just rewrite that. Don't think I like this new tape. 4y minus 2 equals 6. Plus 2 plus 2, or y equals 8. Y equals 2 when you divide. And then the other scenario is this parenthesis set actual bracket group of absolute value is equal to the opposite, because negative 6 also could be the distance of 6. Y equals negative 1. So with that, I need to substitute both these answers back into the original problem. So I have the first scenario, which is 3 absolute value 4 times 2 minus 2 minus 7. Does that equal 11? And then I have 3 absolute value 4 times negative 1 minus 2 absolute value minus 7. Does that equal 11? So simplifying this out, 3 absolute value, negative 4 minus 2, negative 6 minus 7 equal 11. And then 3 absolute value, 4 times 2 is 8, minus 2 is 6, absolute value minus 7 equals 11. So the absolute value of 6 is 6, 3 times 6 minus 7 is 11. That works. Same thing on the other side. Absolute value of -6 is 6, so I'd have this exact same problem, which means both of these work. Since both of these work, my answer is y equals 2 or -1. Mind you, if it doesn't work, then that solution would not work. So sometimes that happens. All right. So the next thing we have are these inequalities. So same thing every single time. Isolate that absolute value bar. Now, this should come out as no solution because you won't get an answer that will be less than -23, but we're going to do the math just to double check. So the two scenarios you have is 2n plus 1 is less than -23, and 2n plus 1, we're going to switch the sign to +23, and since I did that, I need to switch the inequality. Solve it out. -1, -1. Okay, and then same thing with this one. -1, -1. Divide by 2. So on my number line, I have two numbers of choice. I have a -12 and a +11. Now these both have open circles, and I'm going to test scenarios to see when they work. Okay, and my hypothesis is that something shouldn't be less than absolute value wise, but we'll double check. So a number in between here is 0. A number that is in between 11 and something bigger would be 12, and then a number down here is -13. So I'm just going to use my calculator to plug this in, okay? And double check to see if they work. If they work, I'll able to put a green check mark. If it does not work, I'll put a green X. So I'm going to plug in, so 2 times -13 plus 1 is -25. So the absolute value of -25 is 25, so now I have 25 plus 11 gives me 36. 36 is not less than. Okay, plug in 0. 2 times 0 plus 1 is 1. The absolute value of 1 is 1, so plus 11 gives me 12. 12 is not less than or equal to -12, not 21. I like the number 21 today. And then last but not least, going to plug in 12. So 2 times 12 plus 1 is 25. The absolute value of 25 is 25. So plus 11 is 36. So this one didn't work. Since none worked, my answer would be either the empty set, no solution, or you can do empty set that way. But I write my zeros that way. I like no solution. So there's your possible solutions. All right, last one. So 2 scenarios. I have it already isolated as an absolute value. So I have 3n minus 7 is greater than or equal to 11. Or the other scenario is 3n minus 7 is less than or equal to -11. Now I switched the sign because I switched my value of 11, so that's multiplying by a negative or dividing by a negative number. Gotta switch your sign. if you round on this, it won't work. So my two numbers that I'm choosing from are -4/3 and 6. They're both closed dots. And it's a gray tor, so it should be an or, but we're going to make sure. I'm going to plug in numbers, so I like -2, 0, and 7. So I'm going to plug in -2. So 3 times -2 minus 7 is -13. So this is the value inside that absolute value bar. So the absolute value of -13 is 13. So my question is 13 greater than or equal to 11? That is true. So I plugged in -2. That one worked. 3 times 0 minus 7, -7. So the absolute value of -7, because this -7 is the value that's in here, is 7. Is 7 greater than or equal to 11? Nope. So trying 7, 3 times 7 minus 7 is 14. Absolute value of 14 is 14, which is great. Is that greater than 11? That is true. So now what I do is I take my answer, so I want all the numbers up to here. So I want x is less than or equal to -4/3, or n, because it says n. Or, and the or comes from the space in the middle, 6 is less than or equal to n, or you can have it be this answer here, switched it. I don't care. I just let you write your answers based on what your number lines are, and that's the easiest way. It's all the values here, skip, that's the word or, and then all the values this way. So, alright, last thing we have is graphing. So, on this first one, a is a half. You can't see that. Let's try that again. We've got some graphing. A is a half. H is a -4 because we see a +4, and K is -3. So my starting point's -4, -3. My domain is going to be all real numbers because it's an absolute value. My range is going to be y and -3, and then we're going to look at our graph. I know it's going to be greater than or equal to because of my a, but we're going to just double check. So starting point, -4, -3, so -4, -3. Can't see that again. Let me zoom this out. Won't let me zoom out, so let's try that and then zoom in a little bit. Oh, come on. There we go. And like I said, my a was a half, so I'm going to go up 1 over 2. And I'm going to do that on both sides, so up 1 over 2. Ignore that first mark. And then I'm going to take a straight edge. 20% off coupon works. Connect my lines. Connect my line over here. And since all my y's are going up from that value, that's why I said this would also be greater than or equal to. It also helps because that a value is positive. Alright, inequality. Inequalities are done the same way. AH's and K's. So your a value, in this case, is a -1. H value, you see a -3, so it's a 3. Your k value, you see a +3, so it's a 3. So I'm starting at 3, 3. And then this is equal to, so this is a solid line. So I'm going to go to 3, 3. And then my slope, or my rate of change, is -1, meaning my dilation, stretch, is 1, but I do have a reflection. And these are closed circles. And I'm just going to follow that graph out. Make sure you graph the whole line. Once again, this line is solid. Same thing with this side over here. So since that's solid, and I did graph the whole thing, because you got to cover your whole graph, what I want you to do now is I want you to look at your shading. Now, I can't plug in 0, 0, because 0, 0 falls right here on the line. So what I'm going to do is I'm going to pick a number that I like, and I'm going to plug in 3. Also, it's just right here in the middle. So I'm going to check 3, 0. So I'm going to go, is 0 less than or equal to the absolute value of 3 minus 3 plus 3? The cool thing about picking that point is these two numbers cancel out, so I get, is 0 less than or equal to the absolute value of 0 plus 3, meaning is 0 less than or equal to 3. So that's a true statement. So since this is true, I want all the points this way. Okay? And then the other way you can test that is you want all the y's less than. So this says y is less than. So here's where my first y is. It's at 0, and it wants all the values that are less than it. All the values less than. If it wanted greater than, you would shade above. I always test point because I forget that rule until I do these a few times, and I'm like, oh, that rule is so amazing. But I don't remember it. Make sure that I can clearly tell when you draw on a line if it's supposed to be shaded or not. You can do arrows. This isn't a really good graph. That's standard 2.